Good evening. Myself Dr.A.Vaniprabha, Associate Professor, EC Department working in SNS College of Engineering. Today our lecture series is on Gauss Law and identification of electric field intensity by applying the Gauss Law. How can you determine the amount of charge within a closed surface by simply examining the electric field on the surface? How to use Gauss Law to calculate the electric field due to a symmetric distribution of charges. So we are going to discuss on these two today. While determining the electric field or the charge enclosed by applying Gauss law, we shall follow this procedures. If that procedure is followed in sequence, then obviously we can attain the complete charge enclosed or electric field intensity or electric flux density. The first and foremost, you have to draw the figure of the um, charge to be identified. If it is a long wire, you have to draw the figure of a lengthy wire marking all the necessary dimensions. And so as to identify the charge enclosed as per the law, the flux through any closed surface is equal to the charge enclosed by that surface. As per the law, we have to identify a suitable Gaussian surface which is perfectly mapped with the element of that what we are going to identify the charge or field intensity. For example, if the element is a single wire or a lengthy conductor, then the Gaussian surface which perfectly matches or suits with that surface will be a cylinder. And if it is a smaller ball, iron ball, then the particular surface that's used with that iron ball will be a spherical surface. And if it is a infinite sheet or a rectangular sheet, then a cylinder will be best suited so as to determine the field intensity or charge enclosed. So after appropriately selecting the Gaussian surface, we have to determine the dot product E dot dA. dA is nothing but the differential area of that particular element which is taken for consideration, right? So E will be a constant value which can be taken out of the integral, and dA after integration, if it is for example a sphere, it will give the area pi r square. And next is, after determining, identify the value of Q enclosed. Finally, solve the equation for the magnitude of E. These are the steps that shall be followed so as to determine the electric field intensity or a charge enclosed by that particular surface. This can easily be identified by selecting the Gaussian surface appropriately or suitably based on the element, current carrying element. Under electrostatic conditions, any excess charge resides entirely on the surface of a solid conductor as shown here. Electric field is always equal to 0 inside a solid conducting surface. There will be a zero field existing inside the solid conducting surface. Under electrostatic conditions, the electric field inside the solid conducting sphere is 0. Outside the sphere, the electric field drops off in the ratio of 1 by r square, as though all the excess charges on the sphere were concentrated at its center. So this is a simple diagram that represents the distribution of charges as it moves away from the radius or the origin. If it is asked to determine the charge enclosed or the field intensity of an infinitely long charged wire. Immediately, we have to identify a suitable Gaussian surface. The perfectly suitable surface here is coaxial cylinder, which is used to find the electric field outside of an infinitely long charged wire. So here the length of the wire is L, and similarly the height of the cylinder will be L. So the dimensions has to be properly identified and should be properly inserted in the formula so as to get the Q enclosed. And also the one important thing to remember here is once the current carrying element is given, we have to identify the field, in which direction the field will be oriented. The either the field is oriented in the radial direction or in the any other direction of theta or phi. So based on that, the formula has to be obtained and E has to be found. So can anyone answer this question? For which of the following charge distributions would Gauss law not be useful for calculating the electric field? Option A is uniformly charged sphere of radius r, a spherical shell of radius r which uniformly distribute over its surface, a right circular cylinder of radius r and height h which charge uniformly distribute over its surface, an infinitely long circular cylinder of radius r with charge uniformly distributed over its surface. Gauss law would be useful for finding the electric field in all of these cases. Which anyone answer which is correct or best suited for this? Think over and answer me later. The next topic is infinite plane sheet of charge. So this is also a conducting surface which is of rectangular in nature. So as to determine the electric field intensity over this infinite plane sheet of charge, we have to identify a cylindrical Gaussian surface which is used to find the electric field of an infinite plane sheet of charge. See here in the picture, it is clearly represented that the Gaussian surface has been placed above and below the sheet, or the sheet is inserted between the Gaussian surface. Since the Gaussian surface is a cylinder, the cylindrical coordinates are rho, phi, z, whereas it has two linear dimensions and one angular dimension. So rho and z are the linear dimension, whereas phi is the angular dimension. Rho is the radius of the cylinder. Here the field lines are oriented in the radial direction. Obviously, the surface dot for E dot dA or ds has to be selected suitably for the unit vector which is directed in the radial direction. The next is uniformly charged insulating sphere. The electric field of a uniformly charged insulating sphere can be calculated based on the following procedures what we have done earlier for calculating the electric field intensity of a long conductor or a lengthy wire and infinite sheet of charge and for a spherical shell. The same procedure or the same steps has to be followed. We have to identify the suitable Gaussian surface and also you have to predict the direction in which the field lines are oriented. And since this is a sphere, the field lines are obviously oriented in the radial direction AR. And in continuation with this identification of the field vectors, electric field lines, immediately we have to determine or choose the possible or best suited ds formula oriented in radial direction, and we have to apply in the integration. After integrating, we'll get a final value which has to be made dot product with E, and then we have to find the charge enclosed. Here the volume charge density R is equal to charge per unit volume, which is used to categorize the charge distribution. Here in this picture, we can easily identify the charge distribution, which is a ramp and also um, falls linearly, exponentially with the distance. So hope you understood this session of electric field intensity determination of various elements which is distributed with the charges. Thank you for listening. Thank you.